Hello, everyone. I'm Peter Cartmel, and I'm the platform manager at Galvanic Applied Sciences. Today, we have application training regarding LPG odorization. We will provide a process introduction, discuss key challenges, and offer a recommendation. Natural gas goes through many different process steps before it reaches the consumer. As you can see in the value chain, odorization is the final step in natural gas transmission before the natural gas company takes over for distribution. However, today we'll be discussing odorization specific to LPG. LPG is a category of natural gas liquid containing mostly propane and butane. NGLs are separated from the methane and then fractionated into their individual components. NGL specification mandates concentration of sulfur species allowed in the final product. LPG also requires a specific concentration of odorant added to the final product. Odorants are added to the LPG to allow for human leak detection. Common odorant species include isopropyl-mercaptan, tertiary butyl-mercaptan, normal propyl-mercaptan, secondary butyl-mercaptan, and tertiary hydrothiophene. Here's an example of what an odor injection system might look like. These automated systems are used to add exact amount of odor required. LPG odorization faces several challenges. Dosing too little odorant doesn't sufficiently alert the public to a leak. Dosing too much odorant has consumers calling the utility companies claiming there is a leak. Odorant can also fade over time depending on transportation and storage condition. Sniff testing is required, but it only shows a snapshot of the odorant concentration. Odorized LPG travels across hundreds of miles of interstate pipelines. Dispatching sniffers across vast distance is both time-consuming and costly. There are several technologies used to quickly monitor odorant concentration. Drager tubes are used to manually measure odorants. However, the disadvantage is the operator needs a specific tube for each sulfur species. There are also limitations on accuracy. Online Process Analyzer uses a UV method automatically monitor odorants. However, if the performance can be negatively impacted if there are upset or changes in the composition from blending. UV works well for high range measurement, but since odorants are low concentration, accuracy is limited. Online Process Analyzer using a wet cell chromatographic method also automatically monitor odorants. Systems follow this method uses a consumable that is carcinogenic. To effectively and accurately monitor odorants in LPG, we recommend using a chemiluminescence method to measure speciated sulfurs. This provides an echomolar response to all sulfur species from ppb to ppm ranges. Every sulfur in the LPG matrix is measured within 7 minutes. This technology also supports multiple streams to monitor the pre- and post-odorized gas. The best way to complement sniff tests is by continuously monitoring the odorant content. Analyzers quickly identify odorants fading due to new piping, contamination, or side reaction. Analyzers also help troubleshoot odorization performance. DCS will receive the recommended dosing rates calculated by the analyzer. For liquid samples, analyzers are supplied with a sample system that vaporizes the LPG for a smooth measurement. Additional sulfur species can be measured depending on the requirements. This includes H2S, total sulfur, and other specific sulfur species. Chemiluminescent gas chromatograph is an accurate way of measuring odorants. After capturing a sample, sulfur reacts with air and hydrogen under a vacuum at 750 degrees C. Sulfur monoxide is formed and sent to the reaction cell. An ozone generator creates ozone, which reacts with the SO to form SO2 and light. A photomultiplier tube detects the light and generates the voltage. The voltage generated is proportional to the sulfur compound concentration. This method follows the approved ASTM method D5504. We are here to answer your questions about how our Software Chrome GC can support your authorization operation. Please contact our sales team, myself, Peter Cartmel, or your local representative. Thank you.